Our next talk is by Duane Hamacher on Indigenous Astronomy, History, Challenges, and What We Have Learned. Duane is an Associate Professor of Cultural Astronomy in the School of Physics and Director of Cultural and Indigenous Astronomy Program at the University of Melbourne. Duane.
Thank you, Nick. Can you see my regular screen or do you see the
Yes.
presentation? You see
Yes.
regular. Excellent. Thank you so much. So thanks. All right. Well, eventually we'll get there, won't we? We've been doing this for years now. How's that? Good there? Excellent. So I want to thank Nick and Toner for inviting me to come speak today. Um, I'm really excited to be talking about this because it's a topic that I think our community in particular really needs to address and learn a bit more about. So rather than give numerous examples of Indigenous astronomy, what I would like to do is talk about some of the history challenges and misconceptions that we face when we're working in this particular field and get some idea of how we can start to really move forward in a positive and meaningful way. So for nearly 20 years now, I have been working at the interface of astronomy and indigenous knowledges. Coming from the US, I knew next to nothing about the topic, but I began pursuing that as a PhD thesis at Macquarie University when I began back in 2008. So not quite 20 years, but pushing it. And over that time, I had focused most of my research on understanding indigenous astronomy. And I say astronomy in that we're talking about the science of the cosmos. This is a broader definition or a broader concept than what a lot of Aboriginal and Torres Strait Islander elders explained to me is sky country, which is the view of the sky and the knowledges that are encoded within that. Most of my career has been focused on the science of that, but not only. And a big part of this has not just been about understanding Indigenous astronomy, but about understanding how Indigenous astronomy can inform and benefit Western astronomy, but also how ideas of Western astronomy can help inform and benefit Indigenous ways of knowing, something that Martin Nagato calls the cultural interface. But this is an area where there are a lot of tensions, there are a lot of misconceptions, there are a lot of controversies. And I really wanted to spend my time today talking a bit about that. So what I show here are two images of very famous astronomers. Of course, we have Nobel Prize laureate George Smoot, who had done some original research looking at the cosmic microwave background radiation. And we have Uncle Bill Edom Maharney, senior Waterman elder who was full initiated, both of whom have incredibly in-depth knowledge of astronomy and the cosmos, both of whom are extremely senior at the top of their levels, and as we might say in the US, the top of their game when it comes to understanding the stars. But there are similarities, and there are, of course, differences between what they do and what they know and what they share. So, with traditional indigenous ways of knowing, there are a lot of things that wouldn't be stuff that modern astronomers, astrophysicists might care or look at, and vice versa. But it's really important that we understand how these different systems of knowledge, where they intersect, how they can share, and how they can mutually benefit each other. Because I feel we can spend forever talking about differences, but it's the similarities where we find the humanity and where we find important connections. So to really make sense of this, we have to understand a few basic concepts about indigenous ways of understanding the sky. And this is stuff that has come from the elders and the indigenous colleagues that I've worked with over many years. So on the left here, we have Nawit Carolyn Briggs. She's a senior Bunurong elder down here in Melbourne. And she's also an academic at Monash University. She and every other elder have talked about how everything in the land is reflected in the sky. As is above, so is below. If you want to understand how our world that we live in down here works and functions, you can look to the sky. It's an anchor point. It's a point of connection. No matter where you are, you'll always have the stars above. So what does this mean, reflecting as above, so below? Because it can sound to many people to be something very astrological, and we know how that term goes in our community. However, what it's referring to is understanding the stars serve a multitude of functions. The stars can serve as a timepiece, as a map, they can serve as a law book, they can serve as a scientific textbook, they can serve as a memory space, they can be a canvas on which narratives are inscribed and passed down through traditions that describe how things interact between the land and the sky. When I talk about interactions between land and the sky, we're talking about things like stellar navigation, observing when stars rise or set at dusk or dawn to mark out seasonal calendars, using the movement of the sun from solstice to solstice over a year to reckon time, or even observing how different phenomena in the sky can tell us something about what's going to happen in our world down here. For example, the behavior of animals, changing of weather, or availability of different types of food sources. We begin to explore indigenous astronomy, it's important that we're not just looking at the sky. We're looking at the sky and how that links to and relates to everything on the land. And of course, it's not just about some of those more practical aspects, for lack of a better word, but it also links to identity, to spirituality, to language, and connection. And those are things that elders talk to me about, but of course are outside my remit. I'm not part of those cultures, but it's important that we understand what that means and how those things work. In the middle here, we have Uncle Alo Tapim. Uncle Alo is one of the senior elders on Mare, which is a small island on the far east of the Torres Strait. If you've ever heard of Mabo, Eddie Kweki Mabo, native title Mabo Day, this is the island that he is from. And Uncle Alo and all other elders that I've ever spoken with in Australia or around the world say the same thing. Your ability to thrive and survive in your environment depends on your ability to read your environment. In the case of astronomy, that means your ability to read the stars. And reading the stars refers to your ability to observe and interpret everything that you can see about the stars and understand what that is going to tell you. So this might be the movements of the stars relative to the horizon, the movements of planets, the sun or the moon, how the moon goes through phases and the different types of phenomena we see in the sky with eclipses and comets, but also the properties of the stars themselves. We can see their brightness change over time. We can see their color change over time. We can observe how they twinkle. And if you know how to read these things in your local environment, then you can understand how to observe that and forecast weather, predict seasonal change, know when animals might be migrating or breeding or fledging or whatever they happen to do. You can understand how that works if you know how to read the stars. But again, that ties in with the first thing. Reading the stars is inseparable from reading your landscape. So stars and land are inseparable. On the right, we have Professor Martin Nakata. He's the first Torres Strait Islander to earn a PhD in Australia. He's an education specialist, and he's done a lot of work on a theoretical framework called the cultural interface, which I mentioned very briefly at the beginning. Professor Nakata talks about something early when he brought me in for my very first job at UNSW after I'd finished my PhD at Macquarie. And he said, Duane, we are a people of culture. Nobody is going to challenge that. People understand that. But we're also a people of science. And this is something that the public doesn't recognize and the scientific community largely does not recognize. And this is really the main point of the work that I've been doing over the years. And I think one of the things that we as a community of astronomers and historians of astronomy are going to grapple with in different ways. And it's something that I think we need to discuss in more detail. But to do that, it's important to get some context about what this really means. So this is an infographic that I've used for a number of years, and I don't necessarily agree with every aspect of this, but it's basically an idea that indigenous ways of knowing and Western ways of knowing are going to have similarities and they're going to have differences. A Venn diagram of them is not going to be a perfect circle, nor is it going to be two completely separate circles. Western science tends to be very discipline specific and somewhat fragmented, whereas indigenous science tends to be more comprehensive and holistic. Um, on this graphic, it says one uses qualitative and the other uses quantitative data. And I would strongly disagree with that because indigenous knowledges absolutely use quantitative data and science absolutely uses qualitative data. But what we're also looking at here is how science, Western science, tends to find universal truths, whereas indigenous science tends to think about more practical and applied goals and outcomes. As Martin Noctis says, all indigenous knowledge is developed in situ for that local environment and that local region. But both explain complex systems, both seek to understand the physical world. Indigenous science, in many aspects, may go off and try to understand parts of what are considered a supernatural world, which is not the remit of Western science, but that's fine. Both are trying to understand the physical world. Both are based on observation and deduction through logical, inductive, and deductive reasoning. Both are bodies of knowledge that change over time, and this is a really important one. Science changes continually as we learn, experiment, try new things, new information comes through. It's a dynamic system. And indigenous knowledges are exactly the same. They are not static in time, they do change. And both are verified through repetition and through experimentation. Those experiments are often done in very different ways. Maybe different questions are being asked, different applications, different processes. But at the foundation, that's where they intersect, and that's where they're similar. So how can science be embedded in indigenous knowledge? Well, I spoke about how indigenous knowledge can incorporate a lot of things that might not be considered science. So look, I'll just give one very brief example. And this is a traditional story from Northeast Arnhem Land. And there's different variants of this story, but the main theme of the story describes two brothers who were very fond of fishing in a canoe out at sea. And one day they had planned to go on a fairly long expedition out to sea, and elders had warned them to be cautious because the time of year that it was, even though the sky seemed very clear, blue, not a cloud in sight, storms could come out of nowhere and they faced a bit of danger. But the two brothers were confident and felt they would be fine. So they went out and were so preoccupied with fishing that they didn't notice clouds accumulating in the distance. And when they finally did notice that, they began pushing back to shore and realizing the clouds were coming quickly, they started paddling frantically. They didn't quite make it. The storm came up, capsized their boat, and the older brother, who was stronger and more experienced, helped save his younger brother from drowning, but did so at the expense of his own life. After the storm had passed, the brothers had reached the shore, and somebody in the community came down and saw their capsized canoe and called the others. They went down. They found the younger brother. He was barely alive, but he was alive. The older brother, they found sometime later, had passed. He had drowned. And the younger brother, when he sort of came to, explained to him what happened. And the community decided to hold a corroboree, a celebration that evening, to celebrate the heroism of the older brother. And they did that. And when they did, later that evening, a bright star appeared on the sky banks of the Milky Way in the center of the galaxy. And the community saw that as the spirit of the older brother telling them that he was safe with the ancestors. Now, the story is depicted in this artwork you can see on here, and it shows the very center of the Milky Way galaxy, where you would have the Southern Cross off to the right and the stars down towards, you can see off on the left. But the story is talking about this. When you begin to unpack the deeper levels that the story is telling you, goes into much more detail than I provided here, you start to see something interesting. The story is telling you about understanding the positions of the stars and what's happening on the land. That tends to happen at the monsoon season. It's not raining all the time. You can have beautiful weather, but rain can come out of nowhere. And you need to watch the motions of the cloud. You need to watch the water and the waves in the water and the reflection of the water and the way light is diffracted in the sky. If you know how to read these, you'll be able to understand atmospheric conditions. So there's that reading the local environment. But in terms of astronomy, it also gave very specific details about a bright star appearing in the sky near the banks of the Sky River, which is between the light and the dark spaces of the Milky Way, and how many years later, when the younger brother grew to be an old man, that the ancestors placed him in the sky with his older brother, and they became the stars Charlotte and Lasath. Those are the two stars in Stinger of Scorpius. Now, coincidentally, in the year 393, there was an extremely bright supernova that appeared right in this exact spot in the Milky Way. It's not a definitive proof that they observed that supernova, but it certainly is a suggestive indication of that. So, in this context, there are elements of the story that talk about how you have to understand your local environment, how to read everything around you, the water, the animals, the clouds, the sky, and understand the wind currents. But you also looked at the stars. And this is one of the examples where indigenous knowledges talk about transient astronomical events that could actually benefit Western science by sharing these stories about the appearance of bright stars along the planet of the Milky Way, where we're most likely to see supernova, could potentially tell us where we might want to point telescopes to look for supernova remnants, or maybe even help constrain models or observational properties. But the critical thing about this is understanding how this knowledge is passed down. Today, we share most of our knowledge in terms of scientific research through the written word. It's scientific papers, maybe even books. Yes, we give talks, but the real value of our science is in the written word. But with indigenous cultures in Australia and around the world, it's not so much a written language, it is orally based. It's passed down through oral tradition. So this is an artwork by Uncle Cigar Passy, the senior elder on Mare, and he is a pretty famous artist. And he indicates in his artworks aspects of culture and life. And this is an example of an elder teaching a youth how to observe the movements of clouds and the sunset, to be able to forecast weather and seasonal change. And there's a lot of important information encoded in this. And what it's important to understand here is information is passed on through oral tradition. It's also passed on through art. And art and science are things that are really important to understand how they work together. They're not seen as two totally separate ends of a spectrum of some kind, but art and science have been working together very closely for a very long time. In this case, it goes back thousands, maybe tens of thousands of years. But I think the most important element we can talk about here is getting rid of this misconception about what a myth is. Now, over the years that I've been working in this particular space, I personally have not caught too much flack from anybody about the work that I do, except when it comes to the amateur astronomy community. Um, I'm not sure exactly for the reasons behind this, but I have been accused numerous times of trying to teach myth as science. And teaching myth as science, to me, makes no sense whatsoever. Saying you're teaching myth as science is like say you're teaching a book as science. Can you teach a book as science? The question makes no sense because a book isn't science. It can contain science, but it's a method of transmitting knowledge. Myth or mythology is a study of spoken stories. That's what myth means, spoken stories. In this case, myth is not the knowledge itself, it's a medium through which knowledge is transmitted. And myth is mnemonic. It's a way of being able to take lots of information, create a narrative out of that, a storyline that can tell you about science, can tell you about culture, it can tell you about our interactions with each other, and it's used to be something that we can remember, that we can commit to memory. So, in this context, myth is not separate from science. It's simply a mode of transmitting information, which can include science. It may not include science. But one thing that anybody who's gone through training in science communication has been told, the best way to communicate science is to have a story. You have to tell a story. And that is exactly how mythology works. Now, for many years, I hated the term mythology, didn't want to use it. I only used oral tradition. I was very adamant about just getting rid of that word. But I've kind of come full circle, and now I want us to reclaim that word because I'm so upset about the way that it's being misrepresented. But what's important to understand about myth is that it contains valuable, important information about the world around us and how it works. And when you ask the elders about this, they'll say, look, our elders were pragmatic old buggers. We wouldn't have survived if they weren't. If the information we were passing on made no sense or was mythical in the way people today tend to think about it, it would have no application. People would die if they didn't have the right information. But these stories, these songs, these narratives, these artworks serve as a medium for transmitting complex layers of knowledge that are going to include science, but not exclusively. So it's really important that we understand that. It's important as a community that when we learn about Aboriginal or Torres Strait Islander knowledges that might be encoded in a story or a song or a dance or an artwork, that they're not dismissed and said, "Oh, well, this is just mythology. We don't really care about that." The narratives are going to incorporate superhuman feats of strength, what we might think of as mythical animals, humans flying, going to the stars and beyond. Not so much as whether people thought that was something that literally happened or didn't. That question didn't make sense, but it was memorable. It has to be something that's going to be committed to memory and can be passed on over long periods of time. So I really wanted to focus on that and just sort of highlight, as a final note in my last 30 seconds, that there's oftentimes a misconception that science and culture are somehow separated. That what we do is we're trying to understand the physical structure and mechanics of the universe, and quantum mechanics doesn't care about culture. The way the galaxies move or the universe expands or doesn't expand doesn't care about culture. But the reality is the way that we do science is influenced heavily by culture. How we do everything is guided by our cultural understandings. Tono talked about reflexivity and positionality. When we start to understand what positionality and reflexivity are, we can really understand how culture and bias can influence science, what kinds of science we do, and how that can be interpreted. So, as a community, on a final note, it's important that we understand our human connection to our research and how we communicate our research, because that's going to help us understand a bit better how Indigenous cultures do that and how these two worlds can come together and work for a mutually beneficial future. Thank you.
Thank you very much, Duane. Um, that was again most interesting and informative. I've heard you give talks quite a number of times, and I learned every time I learned something new. So thank you very much. We got we have 2.5 minutes to fill in. Um, One thing that you might, if you could talk about very briefly, is how to predict the weather from the twinkling of stars. I mean, that's something you mentioned, and that it seems can be done.
Yes, thanks, Nick. So, one thing that I had learned from elders, which was quite prevalent, is how uh, your ability to observe the way the stars twinkle themselves can tell you about atmospheric conditions. So elders had worked out a few things that were really critical, is understanding that the speed of stellar scintillation corresponds to wind speed, that understanding other aspects that aren't technically scintillation, like the changing of color for
Mm.
stars as they twinkle, um, the sharpness of stars, maybe how clearly you can resolve them. Are they a little bit fuzzy? Are they very
Mm.
clear? In some parts of the world, they'll even appear to almost have tails, and those help you gauge wind direction. But also, you have to look at things around you. What's happening with the animals and the plants and the wind? Do you feel temperature changes? Do you see certain kinds of butterflies fluttering about? Is there a ring around the moon? If you
Mm.
understand how to observe all these different elements of the environment around you, they can tell you about weather forecasting and seasonal change. So, as the final little note in the Torres Strait, there's a transitionary time from the Sager, which is the dry season, to the Kuki, which is the wet season, in this period called the Nege. And this
Right.
occurs around now. And you'll see at the ground level, you'll look up, and even though the ground level, the air is dead still, you'll see stars twinkling really rapidly above. And you know then that you need to begin planting your crops, banana, sugarcane, sweet potato, because the monsoon rains are coming. And the reason for that is up in the Torres Strait, you get the transition from the cool, dry southeasterlies to the hot, humid northwesterlies. But when those trade winds shift, they do so at a very high altitude. So even though it's dead calm on the ground, you don't feel any air movement. You're going to see them twinkling because of that high altitude trade wind shifting. So learning how to read and understand your environment has a lot of really exciting practical applications.
All right, great. Thanks. Thank you very much, Dwayne.